Hello viewers, welcome to e-learning teachers project Uganda. Our program is organized by e-learning teachers project Uganda. You can visit e-learning teachers project and you will find it on YouTube, Facebook, WhatsApp and the like. You can also contact us, yes, on that very number scrolling on your screen for more information. We can give you more work on Flash. Just contact us using our number scrolling on your screen. This time around, I'm Mr. Balaba Abdulhaq taking you through Mathematics Primary 6. Yes, remember our topic is still SETI concepts. SETI concepts. Yes, last time we looked at listing elements of a given or a described set. For instance, you are told that set M are the first 5 alphabets. List the elements of set M. There you had to write A, B, C, D, E. Those are the first 5 alphabets. So they described, we listed. This time around they are listing and you were going to describe what they have listed. Yes, it is now opposite, reverse. So today's subtopic is, can we read, all of us, describing sets. Again, describing sets. Yes, to describe, you are going to tell the kind of members in a given set. You tell us the kind of members in a given set. What do they form? Is it a collection of trees? Is it a collection of prime numbers? Is it a collection of months of the year? So you tell the kind of members in a given set. Look at our examples. Number 1. Statement. Describe the following sets. Describe the following sets. Say something about the following sets. Describe, say something about the following sets so that we can understand them. Look at number 1. Set A equals to Monday. All of us, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Describe set A. Say something about set A such that a person can understand what set A is about. Yes, who can describe set A? Class? Yes, Peter. Those are days of the week. Good. Let me see. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. This is all of these ones are the 7 days that make up a week. Now you write. You are going to describe by writing. I read through, then I will know that these are the 7 days of the week. How are we going to write in form of a set still? Yes, so you're going to say set A equals, open the curly bracket, and you tell us what are these ones. Set O equals to 7 days of the week. 7 days of the week. Close. You have described. You have described. A person will know that all of these ones are the 7 days of the week. Say something about this set. Tell the kind of members in a given set. Let's switch to number 2. All of us. We are going to read number 2. Yes. Good. That is set K equal to 5, 10, 15, 20, 25, 30. Describe set K. Remember, we are describing such that a person will know what are those members about. Now, 5, 10, 15, 20, 25, 30. Think and tell. Are they factors? No. Yes. Tom? Multiples. Multiples? Yes. Multiples of 5. They went on adding 5. Let's see. 5. Okay, let's use multiplication and we see. 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, this 20. 5 times 5, 25. 5 times 6, 30. So, those are multiples of 5. Or else, you can say 5. 5 plus 5, 10 plus 5, 15 plus 5, 20 plus 5, 25 plus 5, 30. Then, you are observing that those are multiples of 5. So, set K are multiples of 5. Are all multiples of 5? Have we completed all the multiples of 5? No, we've stopped on 30, meaning multiples of 5 less than multiples of 5 up to 30. You've not written all the multiples of 5. You come to this one, set M. Set M 2, 3, 5, 7, 11, 13. Think and tell which kind of numbers are those ones. Begin with number 2. The first digit 2. Is it 2 an even number? Yes, 2 is an even number. What about 3? 3 is not even number. Now, don't call them even numbers because the rest of the numbers are not even. Let's see whether are odd numbers. 2 is not an odd number. 2 is an even number. Now 2 has refused. Therefore, this set is not a set of even numbers. So, there is 3 is not a set of odd numbers. Because 2 is not an odd number. This 3 is odd number, but 2 is not an odd number. 3, 5, 11, 11, 13 are odd numbers, but 2 is even numbers. So the set is not, the members are not even. Again, they are not odd numbers. They are not odd numbers even because we've skipped some odd numbers here. 9 is not there. 9 is missing. So they should be in their order. Therefore, are not odd numbers. 9 is missing. Even 2 is not odd. Now, which kind of numbers are these ones? Let's observe. Are they square numbers? Which number do you square to get a 2? No number you can square to get a 2. They are not square numbers. Which number can you square to get a 3? No number you can square to get 3. They are not square numbers. Now, which kind of numbers are those ones? Try any other type of number. Let's see whether they are prime. Will be ordered. Is it 2 a prime number? Yes, it has 2 factors, 1 and itself. No number can divide it. We've passed there. Is 3 a prime number? No number can enter 3 apart from itself. Yes. 5 prime number. 7 prime number. 11 prime number. 13, prime number. All the numbers here are prime. Yes, meaning since they are prime numbers, we are going to describe set M as set of prime numbers, but not all prime numbers on the world, because we've stopped on 13. Therefore, we are going to say, who can tell? How can you write this one? Because we've not written all the prime numbers in the world. We've stopped on 13. Good. Let us count. 1, 2, 3, 4, 5, 6. Nakato has told us the first 6 prime numbers. So we are going to write M, set M equal to the first 6 prime numbers. The first 6 prime numbers. So we have told you, we have described set M as the first 6 prime numbers. Remember in our previous topic quiz, they were giving us, they were describing, for us we are listing. Now they have listed, we are describing. This, come to set L. Set L. Set L equal to 1, 4, 9, 16, 25, 36. Describe. Say something about set L. Which kind of members are in set L? Start thinking kinds of numbers. Which number are these ones? Are they odd numbers? This is odd, and this one is also odd. But this one is an even number, odd number, even number. So I cannot call set L that set of odd numbers. I cannot call it set of even numbers because the numbers are mixed. Which kind of numbers are these ones? Let's see. Are they prime numbers? 1 is not prime, and 4 is not prime, 9 is not prime. All numbers here are not prime numbers because they have more than 2 factors apart from this one. Yet 1 still is not a prime number. 4 is not a prime number because there is a number that can go into it. 9 not a prime number because there is a number that can go into it, that can divide it. And you cannot call them composite numbers because of this one. 1 is not a composite number. Now, which kind of numbers are those ones? Yes, you think. Use your brain and think. You tell us the answer. Yes? No. They cannot be counting numbers. They are not in order. The order is not uniform. Here they skipped. They are counting numbers, but they are not in their order. Here they skipped this minus this 3. This minus this 4. This minus this is not a 5. It is now a 7. So they cannot be counting. They are counting numbers, but again are not in their order. Yes. Yes, Peter. Square numbers. Let's observe whether they are square numbers. Which number can you square to get your 1? They squared 1. They said 1 times 1. 1 times 1 is 1. Let us see this one. Which number can you square to get this? 2. They squared 2. Here, they squared 3. Okay, 3 times 3. They squared 3. 3 times 3, 9. Here, they squared 4. Good. 4 times 4, 16. Okay, let's see the order. 1, 2, 3, 4, 5, 6. Let us observe whether they are square numbers. 5 squared means 5 times 5, 25. 6 squared means 6 times 6, 36. Oh, so these numbers are got after squaring. certain numbers, and numbers that are got after squaring a certain number are said to be the square numbers. Therefore, these ones are square numbers. So we are going to say L equals, we are describing now L. 1, 2, 3, 4, 5, 6. How do you write it there? The first 6 square numbers. The first 6 square numbers. You can say square numbers less than 37. Square numbers less than 37. Okay, let's just use first 6 square.